Hello and welcome to Snyk Live. I'm Brian Clark, and we're going to be learning about malicious NPM packages, in particular, how someone's NPM package will eat your lunch. I don't know what that means and how an NPM package can eat my lunch, but I'm very curious based on that title. As a developer myself, I use NPM packages all the time. I build Node apps quite a bit, open source, personal projects on the side and for work. And we all need to make sure as developers that we're not accidentally installing malicious NPM packages, or maybe ones that we trust already could be malicious as well. I don't know, but I'm eager to find out more and to help myself and you all find out more about this topic. In particular, we have a special guest joining us today, and that is ZB. Let's bring ZB on. Hey ZB, how are you, man?
Hey, I'm good, thanks.
Thank you so much.
I've been installing NPM packages for my entire career, more or less. So that's something that I think everyone has in common. In 2015, I would install a lot of NPM packages and be very happy about it, giving them access to everything. It used to be fairly common to run sudo npm install.
Yes.
You wanted a global package because, why not?
Before we get deep into things, I want to get to know you a bit more. I'm sure other folks want to as well that might be tuning in. So tell us a little bit about you, your background, how you got into doing this kind of stuff, and a focus on security too.
So I've been a software engineer for quite a while now, doing JavaScript first on the front end, then got interested in Node around version 0.8. And that became the core of my career for quite a while. Built some teams, built some applications, and team led some of that. And at some point, it became obvious that we need to look at security more. So there was Node Security Project. That was my first attempt at doing anything security-wise. It was running Node Security Project's CLI on our dependencies. That was before NPM audit. And that's what triggered my interest in building security tools. And it went on to a point where I'm now building security tools full-time. I realized that I was into JavaScript security before I knew any JavaScript or security.
Oh, wow.
Yeah, because the first ever bit of JavaScript that I wrote was actually a set timeout in a function that would invoke that function twice.
Oh, okay.
And it would crash Internet Explorer, including the entire explorer.exe process on Windows.
Well, I guess a real quick thing with the Node Security Project, right? In case people aren't familiar with that, that was a CLI tool that would help bring awareness to and alert developers of vulnerable packages. I forget exactly when it happened. Maybe you can keep me honest here, but that ended up getting absorbed into NPM, right? And it's a
Correct.
part of NPM itself, and that's what we see today as NPM audit, right?
Yeah. So the small team building that project, they wanted some sustainability, and the easiest option to make it sustainable and to add more people on to focus on it was to put that into NPM, because NPM at the time saw it as a potential monetization strategy, as far as I remember.
Okay.
Yeah, to maybe monetize on top of audit, but they were probably too honest with themselves to really pull that through, because why limit access to something like that?
Yeah. Yes. You mentioned that you worked on something called an audit resolver. Can you tell us a little bit more about that? Let's transition into that.
So that's the follow-up to the story about new vulnerabilities popping up more and more. So at some point, it was so difficult to have NPM audit running in CI and getting everything fixed and making the build green that the team started pushing to remove it. Because every time we wanted to push the last-minute changes, because Scrum has a demo day, and on a demo day, you need to show stuff working in staging. And before it goes to staging, it needs to build. Before it builds, it needs to install packages, and we have a guard there that turns everything red. So everyone hated it. And so I sat down one evening, and in the confines of my hobby time, I just wrote an early version of NPM audit resolver, which would take the NPM audit, and it had actually two parts to it. So first, you would go through an interactive CLI and decide which of the things you want to ignore and how. So there's a postpone 24 days, so just ignore for a short while because it's the demo day, and then ignore permanently or for a month to manage. And that's actually, so the tool is there to make those decisions, write them to a file. The file is formatted so that git blame tells you who made which decision. And the commit message potentially has some context for that. And then there's the other CLI that you run in CI, which wraps NPM audit, reads from NPM audit, and filters out stuff that you've decided to ignore. But the biggest feature there was it would not just ignore the vulnerability by name of the package or the type of vulnerability, because with Node Security Project, you could ignore a certain category like regular expression denial of service, which we did. But what if you have a dev dependency that depends on the package with redos vulnerability, and you ignore that, and then your core server component depends on something, and the new version of that library includes the one that you've already ignored in your dependencies. It means now your decision would have been different. So I want my tool to not ignore that one. So I wouldn't ignore by vulnerability and package name, but I would ignore by dependency path and vulnerability ID. The next major version is in the making. It's almost done, and it's been like that for a while. You know, open source hobby time. But yeah, I'm very close to releasing it, and you can pretty much use it. There is potential for some tiny breaking changes, but you can already use it. So you would install npm audit resolver at next.
But yeah, the auto resolver, really cool tool. Thank you for sharing that with us and bringing it to our attention. I'm glad I learned of this as well to start using in my own projects, and maybe some folks out there as well.
Looking for contributors, by the way.
Okay.
I want to share it with the world, not just in terms of usage, but maintenance as well. And there's a bunch of things we could do to make it even better.
The first question I have for you, ZB, is like, before even getting into authoring one, right? Then like one that will eat my lunch and go to that extent, how would you get me as a developer to install a malicious package, right? That seems to me like quite a leap in the, I don't know, my workflow. Like, why would I do something like that? Why would I install your malicious package?
It's unlikely you're going to install a malicious package directly, unless some typo squatting. So I name it something similar, and you might type that in instead of what you intended to. This is one common way. The other common way is taking over a package, and I think if anyone's following Snyk enough to get into this live stream, you've already seen Snyk report on package takeovers, and there's been more than I can easily bring up from memory. But the idea is simple. You go in and you either steal credentials to a maintainer's account, or you convince maintainer to get you on board.
It makes sense to flow into the demo part of things. What do you say?
Yeah, sure. So remember when I said I did some experimentation in like 2 evenings?
Yes.
So that would be the thing you're gonna see now. Okay, so this is a example Next.js app. If you don't know what Next.js app is, you should check it out. It's very nice. And let's look at the package JSON. There's a bunch of scripts here. So I generated this app from their starter kit, and the only change I made is the name, I think, and then installing my malicious package. So let me go to that folder and run. Okay, so this project is Yarn, and if I do clean Yarn install now, it's not going to reinstall everything. So I'm going to repeat what I did earlier. Yarn add my malicious package, and that should be enough. Okay, yeah, so it worked. Now, what I want to show you is that in this project, you can run like npm run dev, start all the software I've happened to have installed just now. And if I open the website, I can see that it changed. Oh, you're not going to see it because I didn't share it, but you can see it here. Now my editor is showing that something changed here in the repository. Index.js has been modified somehow, and there's this new content there. Have you seen me type it out?
No.
No, not really. So the only thing I did was install the package and then start the application, and this ugly message shows up. So I defaced my Next.js application. So there's a package JSON here, super simple. The only thing that this app has in it is a TypeScript file. So this is a TypeScript application, as you can see. It's a bit simple, but still correct TypeScript according to my configuration, because there's a bunch of TypeScripts depending on what you put in here, which is going to reinstall everything like a clean copy. And it didn't really do anything, right? You don't see any changes here. Let's look at the application. Nothing changed. Package JSON, nothing changed. There's no more files here that I could have messed up. Okay, so what this app is doing is it requires a build step because TypeScript. So npm start. So there's app.js. And now my question is, when you're on a TypeScript project and you're building something, especially for the server side, but not necessarily so, do you ever look at the output of the TypeScript compiler?
No, I try to ignore it as much as possible, even when there's errors.
This is fine.
Yeah, there's a bunch of stuff that's here that doesn't seem like any part of the original application or TypeScript bootstrap that it could have added for some of the more advanced language features, right? Compiling down. In case we've built a Node project, I put in this bit, which is taking process.env and writing it out to a file. I might have as well taken the HTTP module and just sent it to my server. If we put that in code in a place where it runs at all, when you load the page with JavaScript in the hash segment of the URL, it's going to get invoked.
I don't think I've seen that before. That's new to me.
If I inject these characters into any website in a way that they actually run, you've got yourself a reflected cross-site scripting. So I introduced that into the application without modifying the application and without getting you to use my dependency. I spent 2 evenings reading through the built TypeScript compiler. So if you npm install your TypeScript compiler, it's a big JS file that's been built from some TypeScript. And it just so happens that it's still readable if you're persistent enough. I found a place where if you modify it, you can inject some code into the result of the compilation of your TypeScript compiler. So there's a function. I made sure this thing is added only once, and also at the beginning so that it's easier to demo. And spot, which is not the best quality if you're looking to be malicious, but for my purposes, it's good. And so what my malicious package does, it goes into the folder above, looks for TypeScript, goes in, finds the file, grabs through it, finds the part that looks like the function I'm looking for. And there's like 4 different functions named the same. So I then need to narrow it down to the one that I need to modify, and then I modify it and leave it that way. So I didn't actually hack TypeScript. I hacked your local NPM installation, and instead of doing malicious things on the spot, I modified the TypeScript that you've already installed in the process. So the regular way you do it is there's a secret encrypted location from which this variable gets populated in CI, and you want your publish script to run in a separate configuration, and that's the only worker that has access to this variable. So if I have a post install script, it runs in a totally separate container that doesn't have access to this, and so a malicious script would not be able to steal this variable. I'm gonna steal the NPM token now. So let's take yeah, sorry.
I don't believe you. I have to see it.
So the first step of this simulation is to run, so it's going to be pipeline simulation build. Okay, something happened, right? And there's a clean publish env folder that has the dist and the package JSON and nothing else. Node modules didn't get copied over. It's only the product of my application, and we can even inspect index.js is still just my benign application that I want to publish. Pipeline simulation, publish. I'm hitting return on that, and it's what it's doing here. Like, take a look. And this is my so this is my evil server, and I got a request containing this / got this from secret location.
Did you tap into the publish script then somehow?
Yes, unfortunately so. This is what it's doing. There's a script that NPM runs. It's called pre-publish only, and it's gonna only run it if you run npm publish to actually publish the content. The thing you need to do, and I have a slide about it, so maybe we could go through it.
Sure.
That's one slide from my presentation on the topic. My recommendation is you spawn a container. You copy just the package JSONs and your log file and your npm rc, if you have one. Then you run npm CI, preferably just the production dependencies, because who knows what's in the dependencies. And if you don't need them, don't install them in there. And then -- ignore scripts is like the clue for all of it. You need to stop the scripts from running. And then you run allow scripts, which I'm gonna explain in a moment. And then you cache node modules. And then in a new container, you do the building. And then you only save the result of the building if that's something you want to publish. And then if you want to deploy your application or publish it to NPM, you create another container, so part of your pipeline, a new workflow or something. And you, first of all, you check out your repository again. So instead of taking the package JSON that you put in cache, don't put any package JSON in cache, because I'm going to hack you with the pre-published script. Just take a clean new copy of your package JSON from your repository. You get the dist folder that you built before, and you check out the clean package JSON, and that's when you're ready to publish. Same with code that you didn't actually need to build. Don't cache it from the previous step, because no matter what technology you're using, if you have an npm install running as part of your build process in one container in your CI, and there's like a Java or C# build running next to it, but on the same machine, like first or after, it's always going to be possible to inject code into that application from your npm dependencies if the malicious scripts actually run.
So the idea is you do all your install stuff in a separate isolated environment, and then when you're ready to do the deploy, you're starting with a fresh version of your package.json, even though in the past one that you might have still had the access to manipulate my package.json, we're not using that instance of it to run the deploy portion of it. We're going to go get a clean setup of that again.
Yeah.
Okay.
That's it. So the package.json file is not just metadata. You need to think of it as code. And if you want to make sure that you're not running any malicious code, you need to take your code from secure sources. How do you know what you can and can't ignore? There's an app for that. It's called Can I Ignore Scripts? And it's mine. So nice. I spent these 2 evenings hacking on the script that can attack TypeScript compiler installed locally and corrupt it. And then I spent like 2 weeks building up this script and scanning some of the NPM most popular packages for post-install scripts and overall install scripts, and then building a database of stuff that you can safely ignore and stuff that you need to keep. They're not all malicious, right? If NPM has this feature, it's needed for something. And a lot of packages need it to compile stuff, for example. So there's packages which you might have in your dependencies that you need to keep running their post-install scripts. So the idea is to create a whitelist of scripts that you are allowed to run, and you can use npm rebuild and give names of packages that you want to rebuild, which means to run their post-install scripts. I want to tell you that there's this lovely thing called Lava Mode, and it's been built by Kumavis. And then I recently joined the team, and I'm also contributing to Lava Mode. And one thing, and the only thing we've improved since I joined, is this capability. So there's a tool called Allow Scripts in Lava Mode. This is still early days of Lava Mode because it's still not very popular. I'm trying to fix that. It is ready to use, and we're gonna start improving the documentation and making it more hype-inducing very soon. But the idea with Allow Scripts is that you run the setup. Allow Scripts will generate your policy and put it in the package.json, but it will also install a funny tool called pre-install always fail. And now, if you try to install your dependencies with install scripts enabled, it's going to fail that process as soon as possible, so that nothing has a chance to attack you. If you run npm rebuild, bignum, and grpc, I can create a malicious package named whatever else that would still run its post-install script if I run npm rebuild bignum. So I find this valuable to make the list shorter and easier to review and less prone to account takeovers. But good news, I think we can stop sharing now. Yeah, there's good news.
We're starting the week off on a Monday, first thing in the morning here on the East Coast, with just lots of scariness, ZB.
So first off, there's Lava Mode. Another good news is NPM has introduced mandatory 2-factor authentication for top maintainers. And they did that before, but it was like 2 digits or something, like really top of the top. And now they're expanding it to most dependent on packages and most downloaded packages. And there's a bigger number of those. So a few more iterations of that, and it's going to be super hard to take over an account for something that's at all popular. So the return on investment is diminishing there. And so that means we're going to get more targeted attacks and less blanket attacks, which is good for general public. And if you've ever heard of compartments and hardened JavaScript and secure ECMAScript, any of this rings a bell?
No.
Yeah, probably not, because it's a coming up standard, which is only now a proposal to TC39, not yet stage 2, even for a subset of it. but we're really working on it, and there's a working proof of concept that's super hard to use now, but it can be used. And effectively, it means, like, imagine you have a string of text, you pass it to the eval function, and you run it. Does that sound like a good thing if you get that text from someone else?
No, definitely not.
No. Okay. So assuming you can, you want to do that because they wrote something that does interesting computation, and you want to run it as part of your application, and you want to avoid all of the possible negative consequences, you can run it in a compartment, lock down your environment, and you can run it as part of your application. You can wrap the compartment around a package that you don't trust. It's going to run someone else's code, and if that code reaches out to your globals or tries prototype pollution, it's just not going to work.
That's good. That'd be helpful. Yeah.
And it exists. So if anyone wants spoilers, just look at my recent activity on GitHub for the last few months. But I'm going to come back then and tell you more about it.
So with that, yeah, we're out of time for today, but for real, ZB, like, this was super enlightening for me. I imagine for lots of other folks that are watching this now live and the recording. So thank you so much for joining us, and looking forward to having you on again, man. So if folks want to get in touch with you, I've got your Twitter here, twitter.com/NAUGTUR, to follow along with your work there over on Twitter. There you go, folks. You can go check out ZB over on GitHub and Twitter, among other places, or just Google him. There you go. And find out some of the cool stuff that he's working on. Get a sneak peek of what he plans to demo in a future stream right here on Snyk Live. Looking forward to having you again. And we'll see you in another stream in the future. All right, folks. Have a good one. See ya.